All right, here we are. We're in section 12-2, and we're rocking a little Johann Sebastian Bach in the background for you folks, for your entertainment. What we're going to talk about today is analyzing arithmetic sequences in series. And when we talk about arithmetic sequences in series, we're talking about plus and minus. So if you can kind of think of arithmetic meaning plus and minus, that's going to help you to remember how these things work. Let's take a look at some of these vocab words. The first one's called an arithmetic sequence, and a arithmetic sequence is a sequence in which the difference between consecutive terms is constant. So we're going to say constant difference. All right, constant difference, and that common difference that happens here, it's going to be in the position of slope if we talk about these things being lines. In fact, they form lines. So we're just going to call it D, and you'll see what that means in a minute. And then arithmetic series is the expression formed by adding the terms of a arithmetic sequence, and we're going to call that S sub n. This is if we just add all the terms up and see what they are. Okay. I got this great little cartoon over here I thought was kind of funny. It says, just a darn minute. Yesterday you said x equals 2, because today x equaled 3 apparently. So I thought that was kind of funny. I hope you guys get that joke, and if you don't get that joke, we're all in trouble. Tell whether the sequence -5, -3, -1, 1, 3 is arithmetic. Now remember, what we said with arithmetic is their differences were the same. So every time they went up by the same number or down by the same number. So if I take a sub 2 and I subtract a sub 1, see, this would be a sub 1, and this would be a sub 2, a sub 3. So a sub 2 minus a sub 1, -3 minus -5 is a 2. And if I take, and you're taking the second minus the first, so now I'm going to take -1 minus -3, and I get a 2 also. And then I'm going to take 1 minus -1, and I'm going to get a 2. And you're going to find that they're all 2. And so each has a difference of 2, so the sequence is arithmetic because it has a common difference. And that's what we had talked about earlier. What do you think about this one? I'm going to give you about, give yourself about 30 seconds. Pause. All right, welcome back. Common difference. All right. If I'm going to do 27 minus 32, I get a -5. If I do 21 minus 27, I get a -6. No, I can stop right there. Didn't work. All right, not arithmetic. Rule for arithmetic looks like this. A sub n equals a sub 1 plus n minus 1 times d. Now d is going to be in the place of slope, and you're going to see that in just a minute. All right, here we are. It says write a rule for the nth term of the sequence. Now remember, this right here is our rule. Okay, so a sub n equals the first term, 2, plus n minus 1. I don't know what the nth term is going to be, times the difference every time. What was happening here? 9 minus 2 is 7. 16 minus 9 is 7. 23 minus 16 is 7. It's always 7, so my d is 7. And then all I do is I give it a little whoop, whoop, and I end up with 2 plus 7n minus 7. So if I do 2 minus 7, I get 7n minus 5. And I hope that looks like y equals mx plus b to you, because that's exactly how it works. M being the slope of 7, that's the differences, and b being the where it would start at -5. And if you think about this being a sub 1, that 2 there, if you think about what a sub 0 would be, which that doesn't exist, but if it existed, we'd go 7 back from 2, and that would get us to -5. So that's that concept. So the 19th term here, 7 times 19 has to be 153 or something like that. Minus 5 is 100 and, oh no, it would be 133, wouldn't it? Minus 5 would be 128. Okay, so 7 times 19 minus 5. All right. The sequence is arithmetic, with the first term a sub 1 is 57, and the common difference, all right, what's it going down by every time? It looks like the common difference here would be negative 12. Because it's going down, your difference has to be negative. If it was going up, your difference would be positive. So I do the same thing. I put a negative 12 where the d is. My first term is 57. And I go through all those same steps. And I end up with 69 minus 12n, or negative 12n plus 69. And when I put a 19 in there, I get a negative 159. And that makes sense that it's a negative, very large number because it's going down, down, down. All right, you pause for a minute and do these checkpoints. All right, welcome back. What's happening here every time? Well, a sub 1 is 9. If I follow my formula, a sub 1 is 9 plus n minus 1. I don't know what n is right now, although in a minute it's going to be 22. And it's going down by 4 every time, so this is negative 4. So whoop, whoop, I get 9 minus 4n plus 4. 9 plus 4 is 13 minus 4n. And if I put a 22 in there, I get 13 minus 88, and that's a negative 75. And a number 3 there, I hope you got 111. I hope you did the same thing. All right, I got another joke for you. This one is kind of funny. Let's get this out of the way. The I is looking at the pi and saying, get rational, you know, because pi is irrational. And pi is looking at the I and saying, get real, because I is not real. And then on the bottom it says, math jokes. If you get them, you probably don't have any friends. Oh, that was fun. All right, so on to example 3. Now, if we utilize example 3 and given different information, and that's the key here. We want to, if they give us a little different information every time. So you got to know when to fill in the blanks. This time they're going to give you a term. One term of the sequence a sub 11 is 41. The common difference is 5. So if I look at a sub n, I'm looking at a sub 11, and I'm going to call it 41. And instead of n, I can put an 11. I don't know what a sub 1 is, but I know my common difference is 5. Well, that means I have 41 equals a sub 1. 11 minus 1 is 10. 10 times 5 is 50. If I minus 50, I get negative 9 equals a sub 1. So a rule for the nth term is a sub n equals, now we know that d is 5 over here, and my first term is negative 9. If I multiply that out, I end up with negative 9 plus 5n minus 5. Negative 9 minus 5 is negative 14 plus 5n, or 5n minus 14. Okay? And you're going to graph this, and it's just a line like we've done before. If I start putting points in there, if I put a 1 in there, well, 1, that's the first term. It better be negative 9 because we've already discovered that. I know the difference is 5, so it's going to go up by 5. Negative 4, 1, 6, 11, 16. I'm just adding 5 every time. Now, we graph those points. The one thing to know is that you do not, they may lie on the same line, but you do not connect the dots here. Okay? And these are going by 3s. So I'm going to be at 1, negative 3 is right here, and 2, negative 4 is right here, and 3, 1, and 4, 6. Now they make a line. We do not connect those dots to make a line. They just make dots in a line. All right? All right? Write a rule for this one. Two arithmetic sequences are a sub 6 equals 7 and a sub 2 equals 87. I hope this looks like 2 points. If I gave you 2 points, 6, 7, and 22, 87, you could find the line between those 2 points. If I said, find the line between those 2 points, all of you would start to work on your slope formula right away. Find the slope, 87 minus 7, 22 minus 6, and you would work through that and find y equals mx plus b. You'd find m, and then you'd find b. This is a little bit different than that, so pay attention. you could use the same formula, though, so don't worry about that. A sub 22 is 87. N minus 1, so 22 minus 1 is 21. And a sub 6 is 7. 6 minus 1 is 5. And what they did is they said, solve it like it's a system. So let's subtract the first term, the first equation minus the second one. 87 minus 7 is 80. And 21 minus 5 is 16D. And divide by 16, 80 divided by 16 is 5. So your D is now 5. All right. And if I plug that 5 back into one of the originals to find a sub 1, so I'll plug it into this one. I'll put a 21 here and an 87 over here. 5 times 21 is 105. And so if I subtract 105 on both sides, I end up, oh, this is supposed to be 87. I end up with a negative 18 for a sub 1. So the equation is negative 18 plus n minus 1 times 5, whoop, whoop, and I end up with 5n minus 23. Now I hope if you guys took a minute and did that as a slope-intercept equation, you could find the same thing as this right here. And go ahead and do checkpoint 4 and 5. Just pause it and give yourself a minute to do it. All right, welcome back. So we're going to find that equation. Remember, it's a sub n equals a sub 1 plus n minus 1 times d. What do I know and what do I not know? Well, I know that a sub n is 107. I don't know a sub 1. That's what I'm trying to find. And I know that 15 minus 1 is 14 times d, which is 12. So 12 times 14 is 120 plus 48 is 168. If I minus 168 on both sides, I end up with a negative 61 there. So a sub 1 equals negative 61. How does that help me? Now I can plug that back into the original, and I get a sub n equals negative 61 plus n minus 1 times 12. And I give it a whoop, whoop, and I end up with a sub n equals negative 73 plus 12n. Okay? And on number 5, the answer there is going to be a sub n equals 121 minus 6n. And a sub 22 on that one was negative 11, so you know. And the first one, the a sub 22 was 191. Okay? You can ask about that tomorrow when we get back to class. All right. Sum of finite arithmetic sequences. So this this finite arithmetic sequences is you're going to find the average between the first number and the last number. I hope you guys are thinking of our friend Carl Gauss here when he was in 3rd grade, because this is what he did. He found the average between the high number and the low number. The high and the low. I like to say high and low. The book says first and nth term, multiplied by the number of terms, multiplied by the number of terms. Remember, this was a Gauss did. And then you divide it by 2, right? So when we're trying to find the sum of the arithmetic sequence that starts at 1 and ends at 15 of n plus 3i. So n plus 3 times 1 is 12, and n plus 3 times 15. 3 times 15 is 45, plus 9 is 54. Okay, and then that s sub 15 means what's the sum of all these when we add them up? What's the sum of the first 15 terms? So it's 15 terms times 54 plus 12 over 2. 54 plus 12 is 66, divided by 2. Sorry about that, is 33. 33 times 15 is 495. Okay? Let's go ahead. You guys take a minute and do that one. All right. And if you did that correctly, 702 is what you came up with. Follow this same pattern right here, and you can ask that question tomorrow in class. A little block to finish us out.